Hello, YouTube. How are we doing, guys? I thought I'd just check in and say hello pretty randomly. I'm just about to start my live web class. So Wednesdays is chemistry day here at TT, and tonight we're going to be doing some just paused myself. I'm just going to be doing some mole calculations with year 12. Obviously, like you guys in year 12 are like way into that at the moment. I'm going to be doing some entropy with year 13s. Now, year 13s is difficult because everyone's doing different stuff at different times. But you know what? We did some lattice entropy that last week. And we're doing some entropy this week. So even if you haven't done it in school or college yet, I'm going to be going through it and hopefully straighten it all out for you. And it should be nice and straightforward. So what I'm going to be doing is I'm just saying hi on YouTube now. I'm not looking at the comments or anything like that on YouTube. Maybe I'll check in just before I wind up. But essentially what I thought I'd do is I just share with you what it's like to be in a TT live class, because you know what, we used to do some live on YouTube and we streamed them all and it was free for everybody and that's fine. But you know what, I just wanted to let you in on what goes on, okay? And you can't see the comments and the chat that's going on in the private Zoom room that I'm going to be starting in just a couple of seconds. But you know what, you can get an idea of what it's like. So if you're not part of TT, it's still free to join this month. All you need to do is use try TT free, all one word, all capitals, TRY TTFREE, and you can sign up to any course you want for absolutely nothing, okay? So if you want to learn a little bit about mole calcs, maybe, you know, I'm going to show maybe the first 10-15 minutes of this class live, then stick around. If not, fine, don't, okay? But I'm going to start my live class now. I'm going to stop talking to you guys on YouTube. I'm going to only be talking to the to my students in the Zoom room, okay? So I'm going to broadcast now and say hello to them. Hello, my lovely people, my students. It's Wednesday. It's 6 o'clock, and that means it's year 12 chemistry time here at TT. So I want to know who's in the house. I want to know who's here with me. I got a good number of people registered for this class tonight, so make sure you say hi. Hi, Nee. Hi, Hussein. Who else is in here? I can see other people in here. Fion, don't you go quiet on me. I know you're in here. I can see Anissa, Jacob, Manisha, loads of people. That's awesome. How are we doing, Stephen? How's our week been so far, ladies and gentlemen? Hey, Arman. Hey, She. Manisha. Alex. That's great. So how's your week been, folks? Anything you want to just moan about before we get going? Anything you want to tell me about? What have you been doing in college? Any pracs you've been doing recently? Actually, chemistry, obviously, everyone's doing loads and loads of pracs at the moment. So what is it you guys have been doing? Shakiba just submitted UCAS. So we got a few year 13s in this year 12 chemistry class as well, which is great because you can never, I mean, if you kind of dip into this AS stuff, year 13s in these web classes as we go on through the year, you don't have to revise any AS stuff by the time you're finished. All right. When you get to the crunch time, you can think I've done all my AS revision. So that's great. Hussein's been doing titrations, having everybody, to be honest, loads and loads of titrations. Armin started doing some organic chemistry today. That's brilliant. Basic concepts. Got to start somewhere. It's like a new language, that. BMAT revision, Manisha. Yeah, I bet that's pretty stressy, actually. I don't know a lot about BMAT, actually, but I know that they're tough, and it's preparation, not revision for it, isn't it, really? It's a bit weird. Ideal gas equation, Stephen. You know what? We'll be covering that next week. Okay, so we're doing 2 sessions on mole calcs in year 12. This one's kind of all based around mass and concentration and solutions and stuff. Next week's all about gases in the main. Okay, so Jessica, yes, yeah, we've been chatting in the course, haven't we, Jessica, about you relearning stuff after a long time. It does take time. Hopefully you saw my comment back to you and you've kind of taken action on that, and that's helped. Electronegativity, yes, Stephen, yes, that is a big part as well. And you know what, if you think you're bored of writing that word now, just think how I feel about having to write a lot about electronegativity all the time. So bonding, mole calc, so we're all kind of in the general kind of same area. That's great for mole calcs. So yeah, bonding, there's a lot more to it, isn't there, She, at A level than you're led to believe at GCSE. In fact, that's one thing at GCSE that is kind of, you know, we haven't told you any lies really at GCSE. So, but you want, I think at A level, it's one of those things where you learn a bit more about the fundamentals and how bonding works. It does tend to start making more sense. You know, it's like, oh, if they'd explained that to me at the time, you know, that makes sense. That's easy, right? So We're going to be doing some mole calcs tonight. So hopefully hopefully you've downloaded the PDF of questions, and I'm just going to share my screen now, just to show you guys which set of questions it is that you're meant to be looking at. So mole calculations 1 live class, what we're covering here: Avogadro's constant, moles and mass, moles and solutions, and titrations. So it's not going to be rocket science, this one. If you've had a go at these questions already, hopefully you found them okay. So these questions here. But you know what we're going to do before we even start, okay, is think about, hopefully you've looked at those videos as well in the course before actually attempting these questions. So regardless of whether you've actually done it in class or not, then you're well prepared, if you like, to have a go at these questions. And like I said, this is really like an introduction to mole calcs. I want to build confidence. There's no point me throwing loads of really hard questions at you to kick off with, and your brain just goes, nope, I'm not having any of that, and then you hate mole calcs forever. So it's about not baby steps, but it's about building up to the more complex calculations, because you know what, I don't think there's any hard calculations in chemistry. There's just difficult sets of circumstances that you get calculations in. It's just seeing the wood for the trees. Now, hopefully, don't worry, Alex. I mean, you can spend way too long on tick boxes, multiple choice ones. Don't worry about it. I'm going to show you some techniques with that as well. But I'm going to start with something. I want to tell you something. I'm going to tell you a secret, and it doesn't matter how difficult the mole calcs get. I want you to remember this process, okay? So this is what I want you to remember. And I want you to write this down, actually. So I want you to write this down. Mole calcs in 3 steps. Now, any question you get has a fundamental basis running right the way through it. It could be the simplest mole calc that you're doing at GCSE. It can be a really complex redox titration you do at the end of year 2. It doesn't matter. They all have the same 3 fundamental steps. And whenever you're faced with a massive question, I want you to remember these 3 steps, okay? So number 1, okay, find the number of moles of something. Okay. Now, in any question, they're going to give you the information you need to find the number of moles of something. It could be that you have a number of moles and you have a mass, and you can work out the number of moles using the molar mass. You have always, 100% of the time got access to your molar mass, your AR or your MR or relative formula mass or whatever it is. You got that, okay? It could be number of moles equals concentration times volume. You've given those 2 things, okay? Or even if it's a PV equals nRT, so number of moles equals PV equals nRT. So number of moles is PV over RT, RT over PV. Which one is it? PV equals nRT, PV over RT. Okay, so you find the number of moles of something, and we're going to put this into practice later. Number 2 always involves stoichiometry. So once you've found the number of moles of one thing, one reactant, or one product, it doesn't matter what it is in an equation. If you know, and I want you to remember this, the number of moles of one thing in an equation, you know the number of moles of everything else present, okay? Everything else present, okay? When you get to equilibrium, it's a little bit different, but for now, stoichiometry. And then 3, convert the number of moles from stoichiometry, or from step 2, into desired, I don't know, answer, I suppose, okay? So you can turn number of moles into a mass. You can turn number of moles into a concentration. You can turn number of moles into a volume. So whatever the question is asking for, is it a mass? Is it a concentration? Is it a volume? Even if it's a molar mass, you can find that, because you're going to be given the other bit of the information that you need in the question to actually do that. So this is the fundamental basis of every single mole calc you're going to come across. Yes, okay, this step 3 can be a little bit more convoluted than this. It's not, but essentially it boils down to these 3 steps. Okay, guaranteed every mole calc question you do will be find the number of moles of something, use a bit of stoichiometry, turn it into something else. Okay, fundamental 3 steps. Everyone on board with that? Give me a hell yeah. Okay, and I really want you to remember that. Okay, really want you to remember that, because whenever you're faced with a big complex question that's like, oh my god, there's just so much information in there, brilliant, everyone's saying yes, that's beautiful. Whenever you're faced with a question, and that's when you can just go and just, you know, you don't know where to start, make a list of the things that you do have. Okay, I've got the number of moles of sodium hydroxide. Oh look, there's a volume of sodium hydroxide as well. Oh, I just happen to know the concentration then, don't I? So it's about sorting, you know, seeing the wood for the trees, sorting out the information to make it more palatable for your brain, because you don't learn questions in chemistry, you learn basic calculations like number of moles equals concentration times volume, number of moles equals mass over molar mass. Okay, so I want you to remember that for later on. So without further ado, we're going to crack on with these answers. So with these multiple choice questions that I've started with, what I want you guys to do is, hopefully you've had a go of these already. These I don't like, mole calculation multiple choice questions, because they take up way too much of anybody's time when you're doing a multiple choice question. So I want you guys to give me the answer for question 1, A, B, C, or D, please, ladies and gentlemen. Everyone's saying A. We've got a cheeky one from Amir. We've got a B from Amir, a C from Theon. Shakiba saying A as well. I'm going to go with the majority here, okay, as an A. So how many atoms present in 2.3 gram sample of pure Na? So Na, mass of 23. I've lost my calculator. So number of moles, of course, equals mass over molar mass. Now 2.3 is our mass divided by molar mass, and that equals 0.1. That is 0.1 moles. Okay, so all we need to do is multiply those 2 things together, okay, and you get the number of atoms. Okay, so 0.1 times 6.02 times 10 to the 23, the answer is A. Okay, so it's like a 2-step thing, that one. Question 2, 1.5 grams of barium hydroxide dissolved in a decimeter. What's the resulting concentration? The second you calculate the number of moles of barium hydroxide, yeah, absolutely, that's the right thing to do. But then it's just a case of finding the concentration. If you know, remember concentration is in moles per decimeter cubed. If you know the number of moles and it's in 1 decimeter cubed of this, then what's our answer, ladies and gentlemen? A, B, C, or D? A few people saying B. B, yeah. All right, absolutely. The answer is B, 0.19, okay? So I'm not going to write out the workings here, but to find the number of moles of barium hydroxide, BaOH2, that is a mass over molar mass. You need to find the molar mass of barium hydroxide. Incidentally, when I say molar mass, that could mean MR or AR or relative formula mass. It's just a general term. So mass over molar mass, once you've found that, that answer would be 0.019. Now you could actually do concentration equals number of moles divided by volume. Well, number of moles is 0.019. The volume is 1 decimeter. Let's not forget, the concentration units are moles per decimeter cubed. How many moles do you have per decimeter cubed? So we've only got 1 decimeter cubed here, and that's it. Jessica, I got 0.0176. I'm assuming the second step, which got 0.0086, was rounded to 0.9, then doubled. Yeah, okay, so yeah, maybe a little bit of rounding in there, absolutely. So what's the actual answer? So barium hydroxide, come on, Rich, let's get your periodic table sorted out. So barium hydroxide, so that is 137.3 plus 32 plus 2. So then it's 1.5 divided by answer. Okay, yeah, so it's rounding, essentially. Yeah, that's what it comes down to. Okay, the hydroxide ions, yes, it gets doubled because barium hydroxide ions, it's not 0.19. Barium hydroxide releases a Ba2 plus and 2 OH minuses. Sorry. Okay, so that's it. Okay, so it's the OH minus ion. So if you find the number of moles of barium hydroxide, you need to times it by 2 in order to find the number of moles of hydroxide ions, and then you can find the concentration of hydroxide ions. So it's this this concept of, just think exploding. Okay, so it's like saying, well, how many hydroxide ions are in 1 mole of barium hydroxide? Okay, well, it's 2 moles because obviously it's Ba brackets OH2. Okay, so that's what it is. Just be careful with that one. It's the hydroxide ions, because when barium hydroxide dissolves, it splits into these, and you end up with twice as much OH minus than you do Ba. Question 3. What mass of sodium hydroxide would need to be dissolved in 250 cc's, everyone's saying it, 250 centimeter cubed of water to create a solution of 0.2 moles per decimeter cubed? So everyone's saying C. I'm going to say that is the right answer, but very quickly, what mass of sodium hydroxide would we need to make that concentration in that volume? Okay, so first of all, concentration equals, sorry, my bad. Number of moles equals concentration times volume. So that would be 0.2 times 250 over 1,000 standard, okay, because we need it in decimeters cubed. So 250 divided by 1,000 times 0.2, and that gives us 0.05 moles. So that's how many moles of sodium hydroxide we need. What mass? Well, mass equals number of moles times molar mass, and that's 0.05 times the molar mass of sodium hydroxide, and obviously it gives us 2. That's 40, isn't it? Okay, 2.0 grams. So you're using both of those equations in terms of mole calcs to get to your answer there. Okay, really, really important that. I'm just rearranging my desktop a little bit. Okay, so question 4. Calcium carbonate thermally decomposes to give calcium oxide and CO2. Calculate the mass of CO2 that be given off the complete decomposition of 20 grams of calcium carbonate. Oh, look at that. My screen is just filled with D. I think we're all going to be correct here by collectively, shall we say. So first of all, number of moles of calcium carbonate, just for anybody that didn't get it, is mass over molar mass, which is 100.1, and that gives us 0.2. Now, when this breaks down, 1 mole of that gives 1 mole of that and 1 mole of that. So therefore, we have 0.2 moles of CO2 gas, and of course, the mass of CO2 then equals number of moles times molar mass, and that gives us our answer at 8.80 grams. Okay, so again, it's a 2-step process, and these are the types of multiple choice questions you're going to get. Last one on this page, a salt solution contains 80% water by mass. How many moles of water are present in 160 grams of solution? So, we've got 8, and that is our answer, 7.1 moles. Okay, Basil's saying Q. Good job, there's not that many options. Okay, so first of all, the mass of water. Okay, how do we find the mass of water? Well, that basically is 80% of 160 grams. Okay, so all we need to do is calculate that, and that equals 128 grams. How many moles of water is that? Well, number of moles equals mass over molar mass. We're using the same equations over and over and over again. So that is 128 divided by the molar mass, which is 18, and that gives us 7.1, and that's our final answer. Okay, you found the moles of water and they did 8% of it. That's absolutely fine. Yeah, absolutely. So 160 grams. You find the number of moles of that, and then do it that way around. Yeah, potato works in exactly the same way. So it's nearly 20 past. I am just going to say goodbye because I started it off. We have been live on YouTube, ladies and gentlemen. So I'm just going to call an end to that. And yeah, we're going to carry on just ourselves. So YouTube people, thank you. Thank you for having a look on YouTube and taking part. Then and hopefully I'll see you in one soon. Okay.